Hey guys, so the video that you're about to watch is basically a part two. If you'd like to see part one of this case study, it's called Electrical Impedance Tomography, Dorsal Atelectasis Corrected with APRV and Proning. So this is part two. The patient only required proning for 24 hours. FiO2 went from 100% requirement to all the way down to room air, and a perfect recruitment of the dorsal area that was completely collapsed. The patient, it's a little bit more complicated. The patient also has a restrictive lung disease and had we believe, a viral pneumonia that had infiltrated the lungs. So everything now has basically reversed itself, and we're in the weaning process. So yeah, so this is basically part two in this video. The patient has been on APRV for 2 days. And was under some heavy sedation. Patient has seizure disorder, autism, scoliosis. So propofol midaz was quite, well, not quite high, but is at a decent dose, because there's also issues with seizures when we wean that. Fentanyl that was high now has been completely weaned off. We have an extended T high, and on this day, I'm attempting to get her breathing spontaneously, hoping to look at the inspiratory flow as well as the volumes that she's able to inspire on the P high setting. She didn't really start breathing spontaneous in this video. If she would have, it would have been a lot easier to look at the P high and to adjust it so that she has the nicest, inspiratory flow, the best volumes. And probably if she would have commenced breathing spontaneously on a well set P high, which is a CPAP level, that would have been really good for additional distribution to the dorsal areas. In retrospect, I'm publishing this I'm publishing this video in retrospect. To be honest, now she was transitioned from a lower P high setting to pressure support ventilation. The we were using with the APRV time-controlled adaptive ventilation. Therefore, the P low and T low were dependent on the patient's own mechanics. We terminate the P high to the P low, that release to the lower P low setting. We terminate that release when the peak expiratory flow goes to 75% of the peak expiratory flow. So we're using the Draeger V500, using the auto release set at 75% expiratory termination. This was landing the P low with her individual mechanics to around P low of 12. So when I transitioned, I went with a PEEP of 14. And then after return and looked at it, the dorsal distribution wasn't collapsing. It was holding pretty good. So I further reduced it to a PEEP of 12. And the thing is that obviously I was weaning down the P high, but the mean pressure with a P high of 22 was around close to 21, 22. When I transitioned to pressure support, it was with a PEEP of 14, it was like 17. So we kind of like transitioned. I looked with the PEEP of 14 to make sure that the whole dorsal didn't collapse. The dorsal distribution wasn't as good as it is on the higher mean pressure, but everything's resolved. So obviously she has a restrictive lung disease. If you're looking at the electrical impedance tomography during the weaning, for sure all of that counter pressure is going to improve compliance. But again, you have to take the whole clinical situation. We can't delay the weaning. So she was switched to pressure support. And by the end of my shift, I had kept her on a PEEP of 12. And that's the end of this study or case study that I'm presenting. So there's, I'm going to present, I'm going to upload this video. Again, you can watch it, but I suggest that you go see the electrical impedance tomography dorsal atelectasis corrected with APRV and proning. That was part 1. And what I'll do is do a live stream where I can get a better, because I have screenshots of the actual images on the electrical impedance tomography. So we might, we'll be able to, during a live stream, if there's people there, I'll make a PowerPoint presentation. I'll plaster all the screenshots there, and we can like look at the actual diagnostic studies, so that you guys can learn the interface of the PulmoVista, plus see a pretty interesting case study. More to come, guys, and thank you for encouraging, for subscribing, press notifications as well. Hopefully we will be getting visitors and guests and people that can come on and talk. So I call my channel PulmoVista 500 Guide to APRV, because we do use APRV selectively in our patients. We don't push APRV on all of our cases. But when PEEP is not working with conventional ventilation, we do not hesitate to transition to APRV under electrical impedance tomography guidance. This is why I post these videos for posterity. Hopefully, as the electrical impedance tomography PulmoVista 500 starts to catch on and it becomes more mainstream in our clinical practice, that when you're first trying to start out with new technology, it's fun to have videos of previous examples. You can learn by those examples. So I'm just putting out the case studies of APRV when we happen to have those selective patients on it. All right, thanks a lot. All right, so now we're looking at that initial drop from P high of 30 to P high of 28. I kept that going over, I can check later how many, probably around 45 minutes. With the drop from 30 to 28, really I'm getting a little, almost nothing. No real, loss of compliance, no orange loss of compliance at the bases, which is great. The lung is holding itself just as good with 28 than at 30. When you look at here, the changes in end expiratory lung volume, we see that we're winning a little here, but we're losing a little there, and it's being redistributed basically. So there's no problem with this occurring. Then after, we can go to your end expiratory lung impedance. This is what we're worrying about, right? When I drop the P high, am I going to start losing end expiratory lung inflation, right? Am I going to, start de-recruiting? And when I look at my reference here, and then I scroll across, so what time is this? This is between 1 and, so it's been an hour. Okay. Overall, the global impedance shows that with the drop, we are not really losing any volume. That is perfect. Up here, the most compliant area with a reduction P high, some is being redistributed over here. There's been a real big switch around between volume there and there. But we see that there's some being redistributed from here to there, and we look at the impedance curves here. They are positive, meaning that we've lost 0 lung recruitment with bringing it down. So it's been an hour from 30 to 28. Now I'm going to do 28 to 26. I'm going to look in an hour, and this is how we're going to wean rapidly.
because everything's resolved with this patient. And, she's on APRV. She's not breathing. We stretched it to 7. The fentanyl is stopped. And we're just, waiting for the narcotics to wear off and get her breathing spontaneously. Okay, so we are at a p-high of 26, maybe a half an hour into it, able to wean down from 30 to 25. The pulse oximeter has a saturation of 99, so we could probably go to room air. The fentanyl should be wearing off. Maybe she will start resuming some spontaneous respirations. As far as 30 and reducing to 26, 30 and 28 seem to be holding the lung very well. Now we're down to 26, so we're going to have to pay attention here. This was, I don't want this closing up, but for now it's holding. And we'll go to the diagnostic panel. I'll show you other stuff. Okay, so I brought it here to the initial p-high setting. So scrolled the reference, and that was at 1 o'clock. So we're just going to go through the whole layout. Okay, so first things first, we just descended from 30 p-high to 28. This happened. Okay, this is end expiratory lung impedance. We can see overall globally it held itself quite well. There was a shift of ventilation that went from here to the right side, and you can see this all throughout the weaning process. There's a shift of ventilation from the left to the right side. That being said, I didn't notice, wasn't paying attention enough. The patient had a pillow, and the left side the patient wasn't flat enough on the back. So, but even with the pillow, under the one side of the back, we still had a very good distribution of ventilation. But this switching from this side to that side could actually just be a representation of the body position. Okay, once we straighten it out, I'm interested to see if this will just kind of like equalize. So we're scrolling over here with the control. So this was after 28, so we did 50 minutes from 30 to 28. Then I came and reduced it to 26. There we go. And let's see over here. Now I'm going to have to pay attention to the left region. There has been, you see here, there was a descent over here, and it held itself, but then all of a sudden from 1357 to about 1420, there was a sudden shift, but I'm pretty sure 1420, what time is it now? Was that when I just moved it? I'm not sure. So let's go back to the actual image, main screen, now that I moved the pillow. The other thing also is when the patient starts breathing spontaneously and comfortably on the p-high level, that will draw more distribution to the dorsal area as well when she's breathing on that CPAP level. So things still look very good. Still quite happy with the results. Volumes are pretty good. 25%, statting 98. Holding well in the dorsal region. So that's pretty much all I have to say for that. I'm going to go to the regional compliance measurements. Give me a sec. Looking over here, we're looking at the end expiratory lung volume in percentage. So what I do like is to see that there's blue in the dorsal regions, and the end expiratory lung volume losses are over here, which is great. Here there is, so there's some volume loss here that's redistributed somewhere else, but that also at the same time made the lung a little bit less compliant over here. The yellow shows up here. This is residual volume delay. Can show that there's in that region different time constants within the alveoli. There could be some cyclical opening and closing, some snapping open and shut. So we actually don't want the yellow. So if we start seeing that increasing, we got to take note of that. The thing is like I would stop weaning right now, but the patient's everything's resolved. So now it's really just to get the patient off the ventilator. Can't really say like, oh well, I'm going to stop here, and I've only weaned to 26 when, well, the FiO2 is good, the patient, everything is great. So we wouldn't want to delay that. So we're just going to keep on keeping an eye on the changes here, but we're still going to push forward. And I think that when the patient resumes spontaneous breathing, and we'll be able to look at the amplitude of the inspiratory flow, and we'll look at the amount of volume, and we'll titrate up and down on the P-high to see where she can get the nicest, amplitude, the best inspiratory capacity, so that we're not too high towards, total lung capacity, and not too low to get that money spot. And that you can just stretch out the T-high, and as the patient's breathing, just titrate up and down and look at the amplitude of your inspiratory flow. That's okay. That's good for now.